So this one. He's given you the rate equation. The value of K is given. It's a first order reaction, right? The reaction has a constant half-life. Explain why this is the case. It's a first order reaction, that's why. Use the information in this question to show that the half-life of this reaction is this. I think we I think we did this question. Let's go skip करें. We're gonna move to the next one. Yeah, the previous one, I think we did that. I said this one. This is what page? This page 6. So everything is given. The reaction is first order with respect to NO and O3 both. So it's NO's concentration, O3 concentration, first order with respect to both of them. And K is 11,000. I think we did all of these questions. One second. Acha, I was doing it on the tablet. That's why. Yeah, platinum. We did this part, right?
Yes, yes, sir.
This one is the one that we probably didn't do. So this one, identify the conjugate acid base pairs in reaction number one. So there's this reaction happening. So acid conjugate acid base pairs pair one. So this is the first pair. Okay, I'm just going to mark them. Okay, that's pair number one. This is the acid, and this one is the base. And the other pair is this one. Ammonia is behaving as the base, and ammonium ions are behaving as the conjugate acid. Because in reverse, this is going to lose H plus one. Okay, is this part clear?
Yes, sir.
So then he says a student investigates the rate of reaction. The student mixes this ion with a large excess of NH3. So when he uses a large excess of NH3, yeah, it's reaction number two, right? So when he uses a large excess of NH3, that means that NH3 is basically playing no role. Its concentration is constant. So the rate of the reaction is now completely dependent on this ion, this one. So NH3 is not doing anything. Can we figure out the half-life for this? You're starting at what? It's 0.21. So the half-life of the reaction would probably, what's half of that? Yoga. Is that the
Point
half?
one zero five. 0.105.
So it's probably this one, right?
Yep.
And that gives me this value. What's the second half-life? It's probably going to be, well, something close to zero point 0.5, right?
0.0525.
Okay, and that gives me, so it's probably, I think it's equal half-life, right? I mean, I made a rough diagram, but this is like somewhere in the middle. That's 500, and that is going to be something slightly greater than 1,000, right? So it's
Yes, sir.
kind,
Double नहीं हो रही.
but it's constant half-life, right? It's 500 for the first, 500 for the second one. So this means the rate of the reaction with respect to this one is order one. Is that clear?
Yes.
Use the graph to show the reaction to is first order with respect to this. We did show that. You draw the lines and you tell them that the half-life, tell them value of the first half-life, that the first half-life is 500 seconds or something close to it if you measure it accurately, and the second half-life is also approximately 500 seconds. So that means it's got constant half-life. That means it's order one. Explain why a large excess of NH3 needs to be used in order to obtain the results. Because you want NH3 to play no role, to keep its concentration constant. Is that clear?
Yes, sir.
Yeah. And then he's given you a table and he's trying to figure out. The first thing is I'm going to try and figure out the order because he's keeping this ion concentration constant, right? So that means this is not doing anything. What is the change that's happening over here? क्या change है? That's 0.3 to 30 to 45. So that's 0.0045 divided by 0.0030. Is that 1.5 times? Yeah, can you do this on your calculator?
3/2 आया.
So that's 1.5, right?
Yeah, 1.5.
What is the factor over here? 2.21 divided by 1.47. I think that should be 1.5 as well, right?
1.5, yes.
So that means the order with respect to ammonia is order one. And the way you're going to describe this is you're just going to state that if you compare experiments one and two, the concentration of ammonia increases by 1.5 times, and the rate of reaction also increases by 1.5 times. So that means it's order one. So that indicates that the rate of the reaction. This was order one by the half-life method, right? We already discussed this as being order one. So it's order one with respect to both of them. Is that clear?
Yes, sir.
So how do you know whether it's going to be SN1 or SN2? So that is because the rate of the reaction depends on both of them, right? Now, for this, you need to know what SN1, SN2 is. Uh, so if you don't remember SN1, SN2, remember there used to be halogenoalkanes where you had a primary halogenoalkane and that had an SN2 mechanism. So this has to do with organic chemistry. So we'll just revise SN2 a little bit. The ammonia would come in, and the ammonia would get attracted to the carbon that's positive, and the Cl would get knocked out, and you would get an intermediate. Not an intermediate, you would get a transition state where the Cl is breaking off and the NH3s is joining in. And in the next step, the Cl breaks over. Now, this was a one-step reaction. So when it's a one-step reaction, then that step alone is the only step, and that is the only step. So that is your slow step. The entire rate depends on that single step because it's just got one step, right? So the rate of the reaction will
Yes.
be first order with respect to both reactants. It will be first order with respect to the halogenoalkane, and it will be first order with respect to ammonia as well, right? Is that clear? So it is
Yes,
going
sir.
to be SN2. There was another mechanism which was SN1, which was for tertiary halogenoalkanes. उसके अंदर you had carbocations getting formed. In that, what happened was it was a two-step reaction. In the first step, the Cl would break away, and what you'll get is a carbocation. And in the next step, then ammonia would come in with its lone pairs and will get attracted to it. So it was a two-step reaction. And the first step was the slow step. The slow step involved only one of the reactants. So the rate of the reaction was only dependent on the slow step. It wasn't dependent on the next step, because that was the fast step. Rate was only dependent on the halogenoalkane concentration. That was order one. It was not dependent on the ammonia concentration because that was in the fast step. You increase the speed of the fast step, the rate of the reaction does not change. So that's why it's going to be the first one because it's order one with respect to both of them. That's what we found out. So it has to be SN2. Is that clear?
Yes, sir.
ठीक है आमने is this clear?
Yes, sir.
Okay.
Yes.
Okay, so next one. Describe the effect of an increase in temperature on the rate of reaction. That's easy. That's like O levels. There's going to be more kinetic energy, so you'll have more frequent and more effective collisions. So when an excess of this is used, further substitution reaction occurs. One product, so that's organic. I think we can leave that. That's got to do with shapes. Where's the rate? That's more to do with electrochemistry. Yeah, this one. the rate part. He's seeing a student collect some data for the reaction of H2O2 with IO3 minus 1. So he's talking about I think he's talking about the previous reaction. This one, H2O2, H plus 1, and IO3 minus 1. And you want to figure out the order of the reaction with respect to each one of them. So that's exactly what he's looking for. It's just a 3-mark question though. So tell me, which experiments would you compare if you want to figure out the effect of H2O2?
So 1, 2.
You want H2O2 to change and you want the other reactant concentrations to stay exactly the same. Is that
Okay,
clear?
2.
3 and 4?
So it's going to be 3 and 4, yeah. So if you compare 3 and 4, that's what, 1 point? I mean, these are not changing, so that's out of the question. So that's 1.5 times. And that's, I think, can you divide 8.82 divided by 5.88? That's probably going to be 1.5 times as well. So the rate increases 1.5 times as well. So what do we get? It's order 1, right? Is it 1.5, the other 8.82 divided by 5.88?
Yes, sir.
Okay, so that's H2O2. Now, so that's what you're going to write. You're going to write that you compare experiments. Remember, there's a solve worksheet. I've sent the solve worksheet as well. You compare experiments 3 and 4. H2O2 concentration increases by 1.5 times, and the rate also increases by 1.5 times. Hence, the order with respect to H2O2 concentration is 1. Now, focus on IO3 minus 1. Which experiments would you compare for IO3 minus 1? Yeah, are there any experiments which you can
Oh,
compare?
2 and 3? Wait,
Anybody
no, not 2 and 3.
because H plus 1 is also changing, right? But I don't think there's any experiments that you can compare for IO3 minus 1. Are there? Well, 2
No,
and
sir, I
3.
don't think you can
Okay,
compare
so we can
compare.
skip IO3 minus 1 for now. What about H plus 1?
Also, I don't think there's any like that you could compare, which is weird.
Okay, so you can't compare those. Actually, there are two of these in this case. Uh, okay, so this is what you're going to do. Now, this is going to be slightly more complicated. Uh, so remember, we know H2O2. We know what effect that will cause, right? So learn how to do this now. So remember, you know one of the orders, right? So even if that changes, you know what effect that will cause, right? So we can allow that value to change because I know exactly what effect that will have on the rate of the reaction. Do you get my point? So for example, if I compare experiments 1 and 2, right? The concentration of H plus 1 doubles, right? Is that clear?
Yes.
IO3 minus 1 is not playing any role. And the concentration of H2O2 also doubles, right? Now the thing is, I know exactly what this will do. It's order 1, right? So if its concentration doubles, the rate of the reaction should double as well, right? Is that clear?
Yes.
So that means if I double 1.47, that's going to give me 2.94. Is that clear?
Yep.
Yes.
So what effect is doubling the H plus 1 doing then? It's not doing anything, right? Like I know that H2O2 doubles. So the rate of the reaction should double because of H2O2 because that's order one, because I figured that one out, right? So that means this is exactly what the value should be if H2O2 doubles, right? So that means doubling H plus one is not really doing anything. It's not adding anything to it. Is that clear?
Yes, sir.
सही था सर what if it's the opposite H plus की वजह से हो रहा हो H2O2 की वजह से ना हो रहा
नहीं, अभी तो let's be specific now. We know that and we're going to do more questions like this as well.
हो okay.
Like in this specific case, I know that H2O2 doubles, so the rate should double because of H2O2. And it doubles,
सही है
it becomes 2.94. So that means if H plus 1 is doubling, that is not causing or showing any effect on the rate of the reaction. So that means order is what? Order is 0 with respect to H plus 1. Is that clear?
सर अगर initial rate of reaction double की जगह like 4 times हो रहा था then H plus वो order 1 होता
Exactly. Like if it wasn't 2.94, if it was like what's double of 2.94? That's 5. कितना होगा? That's whatever 5 something, right? Then
yes
that would have meant that the rate of the reaction is doubling, and that was probably caused by this thing. But at this
सही
point, this thing is not showing any effect on the outcome of the rate of reaction, right? So that's order
सही
zero.
था
Achha, so now things are easy. So that means H plus one is not doing anything at all. It causes no effect. So the last one is going to be easy. I'm going to compare for IO3 minus one. I'm going to compare experiments 2 and 3. So H2O2 is out of the question. It's not causing any effect. H plus one is also out of the question because I know it's order zero. So even if it changes, it's not going to cause any effect on the rate of the reaction. Is that clear?
yes sir
So that means all the effect that's on the rate of the reaction that it is doubling, right?
yes sir it is doubling
And this is also doubling, right? So that means this is order one, right?
yep
Is that clear? So if I compare experiments 2 and 3, this does not change. So this is out of the question. This becomes half, but it's order zero. We figured that about that one out, right? So that means whatever you do to this, it would not cause any change on the rate of the reaction. So we can ignore that. The only thing that's causing the change in rate of reaction is going to be this one. It's doubling, and that's also doubling. So it must be order one. Is this clear? This one?
yes
So this is slightly difficult. And you have to stay. Remember, it's just 3 marks. There's a mathematical way of doing this as well. I'm going to show you the mathematical way as well. Anyways, you can find the or figure out the rest. Let's try and yeah, this one is kind of easy. It's you have to figure out the order with respect to both of them. So which experiments would you compare for OH minus one? Like,
1 and 2.
so this is not changing. This becomes 4 times, right? What happens to this? What's 2.88 times 10 power minus 3 divided by 7.2 times 10 power minus 4? What factor do you get?
सर नहीं करें 4 yes
4, right? So what is the order?
2
1.
अच्छा 4 है okay I thought it was 2
Well, 2 would have been if this was twice and this was 4 times. So that's a squared
सही
relationship.
yep
This is directly proportional. You increase this by 4 times, that increases by 4 times as well. So that is order one. So we figured that one out. Uh, then which experiment should we compare? That's
1 and 3.
okay, so we're gonna compare 1 and 3. This does not change, so not causing any effect. That becomes what's 5 divided by 2? That's 2.5 times, right?
yes sir
So what is the factor over here in the rate of reaction? 4.45 divided by 7.2. What is that?
6.25.
So you're getting 6 point.
25.
What kind of relationship is that? I mean, that's definitely not order.
डबल हो रहा है. Yes.
No, it's not doubling.
Uh,
Is it a squared relationship? Like
yes.
what is the square of 2.5?
2.5 square is 6.25.
Yeah, that means it's order 2, right?
Yep.
Is that clear?
Right.
So so that means rate is it's going to be a squared relationship. It's going to be order 2. Is this one clear?
Yes, sir.
ठीक है, Amna, is this clear? Zaina, is this clear? Zuhair?
Yes, sir.
Yes. Yes,
Okay.
sir.
ठीक है, the remaining part, let's do the remaining question as well. Then he says use your answer to construct the rate equation. So we figured out ClO2 order 2, OH minus 1 order 1. ClO2 is order 2 and the OH ions was order 1 and you're going to have K. And he's saying use your rate equation and the data from experiment 1 to calculate the rate constant K for the reaction, include units of K. So you have to find K now. And he says data from experiment number 1. So what you can do is you can plug in any of these values and you'll find so we'll plug in the first experiment values. So it's 0.02, 0.03, I think. So 0.02 squared times 0.03, that's power 1. And what is the rate that did they give in the first experiment? That was 7.2 times 10 power minus 4. Now, can you
60. Very constant.
60? K is 60?
Yes.
Achha, and you have to find the unit as well. So K is what? K is the rate divided by ClO2 concentration squared and OH minus 1 concentration power 1. So what is the unit of rate that he's using? It's mole per dmq. He's doing it in minutes. So the rate is mole per dm cube per minute, and the concentrations are in mole per dm cube. Make sure you take the units from here because remember that don't use your own units. Sometimes, most of the time, it's mole per dm cube per second, but over here he's doing that in minutes, right? So we're gonna use those units that he's using. So mole per dm cube per minute. I'm just going to take mole per dm cube as x. So mole per dm cube squared and into mole per dm cube. So what do you get? You get x minus 2 and minutes minus 1. So the unit is substituting mole per dm cube once back into it. It's going to be mole minus 2 dm6 and minute minus 1. Is this clear?
Yes, yes, that's right.
And the value was 60. Now, the decomposition of benzene diazonium ions using a large excess of water is a first order reaction. And we can check for a first order reaction, the half-life is probably going to be, it's probably going to be constant, right? Which I think it is, right? So kind of the same time required for the second half-life. Draw the structure of the organic product formed. Use the graph to determine the rate of reaction at 100 seconds. We're going to do the rate question at 100 seconds. So at 100 seconds, you're going to draw a tangent. Put a ruler and draw the tangent, and the gradient of this tangent is going to be the rate of the reaction, which is uh, the difference in y, that's point what? 17? 0.017. and y over x, right? So x-axis, that's 340, right? Exactly. Clear the rate of reaction at 100 seconds. Is this clear?
Yes, sir. Yeah.
Sketch a concentration time graph for a zero order reaction. Use a graph to suggest how successive half-lives for a zero order reaction vary as the concentration. So a zero order reaction, the reaction will simply not slow down. So it's just going to be a straight line. The gradient will not change. Is that clear?
Yes.
And the successive half-lives, they would decrease. The first half-life would be the biggest one. Second time, it's going to be like really small. Third one is going to be even smaller. So every time, the half-lives will decrease. So here we're done with this. Let's do some more questions related to, let's do slightly older questions. I think
Sir, after this, which chapter are we gonna do?
we're going to do chemical equilibrium.
Okay. And you revised your previous chapters as well, right?
Yeah.
Okay.
So one second. Yeah, this one. I think we did this in class. Let's do a slightly more complicated one. I guess yeah, this one. This is similar to that one. Which experiments would you try and find out what the order of the reaction is with respect to which experiments would you compare?
2 and 3.
Okay, so if you compare 2 and 3, this is not changing, it doubles, and that becomes 4 times, right?
Yep.
So what is the order with respect to NH3?
2.
So with respect to NH3, that is 2. So you figure that one out. How do I figure out the ClO minus 1 concentration? Now we've got a problem and that is that I have to keep this constant, but it's not constant, right? So if I compare 1 and 2, right? The concentration of ClO minus 1 doubles, and the concentration of NH3 also doubles, right? Now, I don't know what this doubling would do, but I'm pretty sure what this doubling would do because it's order 2, right? So
Yes.
that will make it 4 times. What is 4 times
Yep.
of 0.256? Kara, what's
1.02.
so that's going to make it 4 times, so that's going to give you 1.0. Can you put up the 1.02? Exactly one.
1.024.
Okay. So I factored in what ammonia is doing, right? You double it, it becomes 4 times. But the answer over here is 2.05. So that means that there's another doubling that's happening. And that doubling is probably happening because of ClO minus 1. Is that clear?
Yes.
So there's another doubling that's happening, and that's probably because of this. So that means this is order 1. Is that clear?
अगर सर अगर 2.05 डिवाइड बाय 0.256 करें तो आंसर 8 आ रहा है.
Huh, so
तो
I know it's because of this doubling, it's 4 times.
यस.
So how do you go to 8? That means you're doubling it again, right?
अच्छा, तो ये टाइम्स 4 क्यों नहीं है, 2 है ये तो.
क्या?
इनिशियल रेट में जो 1.024 से 2.05.
नहीं, that is 2 times. How do you
तो
go from
कंबाइन कंबाइन 6 हो रहा है इधर, 6 टाइम्स हो
नहीं,
रहा है.
combine 8 हो रहा है, that's into 4 and then it's into 2.
अच्छा, ओके, 2 4. ओके, सही सही सही.
ठीक है, is that clear?
Yep.
भाई ये confusion थी ना, so that's clear.
Can you explain one more time? Wouldn't this be second order then?
with respect to ClO minus 1.
Yeah. No, yeah.
See, you get this point, right? That we already knew that ammonia is order 2, right? Is that clear?
Yeah.
So if ammonia, so I'm going to factor this one out in because I already know what this is going to do. So ammonia is going to be doubled, right? So the rate of the reaction will become what, 4 times? So it should be 1.024, right? Is that clear?
Okay. But like, shouldn't you compare when ClO is constant, so like 2 and 3, to find order 2 of ammonia, right?
No, we've already done that.
Yeah. And then this one, to find ClO, we don't have the constant.
Yeah, so we don't have a constant, right? So what we're going to do is we're going to compare 1 and 2, right? But since we already know what ammonia is doing, I'm going to factor that one in. This is being doubled, right?
Yes.
So order 2 means that the rate of the reaction will become 4 times, right?
Yeah.
So it should become what, 1.024, right? Is that clear? So
Okay.
what I've done is I've factored in ammonia because I already knew what ammonia was doing, right? Now, what is happening to ClO minus 1? That's being doubled, right? In 1 and 2, right? Well, ammonia says that the rate of the reaction should be 1.024. But what you're getting is 2.05. That means that the rate is becoming 2 times once more, right? So the extra 2 times, why do you get that extra 2 times? That's because of ClO minus 1, because you're doubling ClO minus 1. Is that clear?
Okay, so what would the order of ClO be then?
1, directly proportional because,
Because you're just doubling it, so it's times 2. But if it
yeah.
was 2, then it would have been times 4. Yeah.
Yeah, if it came out to be 4 times over here, then it would have been order 2.
Okay.
There's a mathematical way of doing that as well. That's slightly longer. The mathematical way is when you're stuck, when you don't find two experiments. So see, you've already have this order 2, right? And we're comparing 1 and 2. So what you're going to do is you have a rate equation. You have a partial rate equation now. And that is the reason you're not supposed to do it mathematically is because it just carries very little mark. I mean, you don't spend 10 minutes doing solving something for 2 marks. So you should learn how to do this directly. But anyways, this is the longer method, the mathematical method. So the rate equation is that the rate of the reaction depends on these two reactants, ClO minus 1 and NH3. Now you already know that it's order 2 with respect to NH3, right? And you have no idea what the order is with respect to ClO minus 1, right? So I'm going to plug in experiment number 1 values into it. So experiment number 1 is 0.256. That's experiment number 1 is 0.256. K, I'm not sure what K is. ClO minus 1 is 0.2, and that's power X. NH3, that's 0.1, and that's squared. Now, using this, I can figure out what K is. So K is what? 0.256 divided by 0.2 power X and zero point 0.1 squared. So I found out K. So remember, this is experiment 1 values. Now what I'm going to do is I'm going to plug in these values and use experiment number 2 data. Now if I put in experiment number 2 data in the same equation, so the rate of experiment number 2 is 2.05, and you've got K, and ClO minus 1 concentration is 0.4, and that's going to be power X. And ammonia concentration is what? It's in experiment number 2, that's 0.2, and that's going to be squared. Now I'm going to plug in the K value from the previous experiment. And if I do that, that's going to give me 2.05. That's K is what? K is 0.256. divided by 0.2 power x and 0.1 squared into 0.4x and 0.2 squared. And then I'm going to rearrange everything. I'm going to take all the numbers to the other side. So it's 2.05 divided by 0.256 into 0.1 squared divided by zero point 0.2. And I'm going to keep all the x's on this side. So that's 0.4x divided by 0.2x. Can you solve for this? This is, I think, 1 over 8, and this is, what is this? This is 8, and that's 1 over 4. Can somebody solve this?
सर 2 आ रहा है.
2 or and what is 0.4 divided by 0.2? That's 2 to the power x, right? Well, 0.4 divided by 0.2 is 2, right? So what is
Yes.
x? X is equal to
Oh, 1.
1. Now you're not supposed to do this, and I mean that's the mathematical way, but it's a 2-mark question. They're not actually looking for this in this question. But remember, if you ever get stuck, what you're going to do is you have the rate equation, you have the partial rate equation. You weren't sure about x, right? So here's what I did. I plugged in experiment number 1 values into the rate equation, right? And after that, once I did that, I found out k. I plugged in experiment number 2 data into the same rate equation. So I had two expressions, and then I simultaneously solved them. I took the k from the first one, and k was a constant, so it had the same value. So I plugged it in the second one. When I did that, I simplified everything, and eventually I got 2 on one side and 2 to the power x on the other side, and that showed me that x is equal to 1. But that's like a really, really long method. So basically, what you just had to do was you had to figure out that this is becoming 2 times. So because of ammonia, whose order you already know, this will become 4 times because it's order 2, right? And that will give you what, 0.1024. But the problem was that your rate that you're getting is double of that. So that is because this is doubling, and your rate is further doubling because of that. So that means it's order 1 with respect to CLO minus 1. Is this clear? This one.
Yes, sir. समझ में.
ठीक है, what we can, I mean, the others are, let me just find one more graph question. Now, this one has the same issue. Uh, you can figure out AuCl3 order, right? What's happening? Double? What's happening to the other side? EK order. I think that's doubling as well, right? 15.3 divided by 7.66, right? I mean, take this number. So that's doubling as well. So AuCl3 is order 1. So you found one of the orders. Is that clear?
Yes.
So now you have the mathematical method. You can make 2 rate equations. You're going to take this as x. You're going to plug in experiment number 1 data and experiment number 2 data, or uh, and then you're going to try and solve this simultaneously. I said, but over here, what I'm going to do is I'm going to compare. Now I want to figure out H2O2, right? So H2O2 should change. So let's do 1 and 3. So this becomes what, double, and I don't know what's going to happen to the rate, right? Uh, this is becoming 3 times, right? Is that clear? Now I know
Yes.
because of this becoming 3 times, the rate will increase and become 3 times. So what is 7.66 times 10 power minus 2 into 3? What do you get?
It's a rate of production of experiment 1 and experiment 3 का करना है ना.
Well, I know this is 3 times, right?
Yes. तो 6 आ रहा है.
You're getting 6 over here. 7.66 times 10 power minus 2 times 3.
times 3. Okay.
But I know what this will do. It's order 1, so the rate of the reaction will increase 3 times.
2.298.
So you're getting 2 point. So you're getting
298.
2.298, right? Times what? 10 power?
Sorry, 0.2298. 0.2298.
That's 0.2298.
Yes.
So you're getting 0 point. So this is what you're getting. But the answer over here is 4.6 times 10 power minus 1. So I've factored in AuCl3's effect. Now H2O2 is doubling, right? So that means the rate is becoming 4.6. So what is the factor over here in play? I think that's 2 times, right?
2. Yes, 2 times.
So that means this is doubling and the rate is further doubling to 4.6. So that means it's order 1, x is 1. Is that clear?
Yep.
Okay. So is this clear to everyone?
Both of them are order 1, right?
That one we figured out order 1 because we compared experiments 1 and 2, right? That doubled and the rate also doubled, right? So I already figured out that one was experiment number 1. The problem
Okay.
was with this one because I couldn't find any
You don't
experiment.
have a constant.
Yeah,
Yeah.
the other one had to be kept constant. So now I had to factor that one in. It was becoming 3 times, so I knew that the rate of the reaction will become 3 times, so it should be 0.2298. But eventually it was 4.6, so that means it got doubled again, right? So this extra doubling is because of this doubling.
Yes.
So that's order 1. And if you want to spend a lot of time on this, there's the mathematical method of solving 2 rate equations simultaneously, but it's just a 3-mark question and you don't have enough time for that. Okay? Okay, let's continue on Monday then, right?
Okay, sir.
Okay. Bye, sir.
Okay, take care.
Thank you, sir.